Good afternoon, everyone, and thank you for attending today's presentation. Today's presentation is called CAMWorks Tips and Tricks, and my goal is to show you at least one new useful tool/setting that you were not aware of before. This presentation is geared more towards newer CAMWorks users, but it may also contain items that veteran users were not aware of. So my name is Alejandro Murillo, and I will be your presenter for today. I am an applications engineer here with GSC, and I am an expert in various SOLIDWORKS products, but currently my main area of focus is CAMWorks. The agenda for today's presentation is to explore CAMWorks options, recognize pockets with fillets as 2.5 axis features, defining our stock coordinate system, the difference between 2.5 and 3 axis volume. We'll explore some different simulation operation settings. We'll show you how to create a single plunge groove cut. For example, if your groove is the same width as your grooving insert. We'll also take a look at how to use SOLIDWORKS sketches to define machinable features. And finally, we'll take a look at how to deburr the bottom of a hole using 2.5 axis features. We'll begin by exploring some CAMWorks options that you may have not been aware of. We'll take a look at some settings under the Mill Features, Update, and Display page. The first setting under the Mill Features page that we'll take a look at is the Spline Deviation setting. This option allows you to define the tolerance applied to splines for rough mill and contour mill operations. Specifically, whenever you are machining spline, ellipse, or text entities, this deviation value will have a direct impact on the accuracy of the spline or ellipse shape. The image shown on the slide gives you a visual image of what happens to the spline shape when you have too large of a spline deviation value. You can see the green line represents a large spline deviation. On this slide, I have a recommendation value. Your value should be less than 0.003 millimeters or 0.0001 inches. On this slide, you can see spline deviation can directly impact how your 2.5 axis feature shape is defined. The example on the top shows a high deviation value, where the example on the bottom shows a small deviation value. If your deviation value is too large, you will see facets instead of a smooth spline on your machined part. Next, let's take a look at a real example of what happens when that spline deviation value is too large. So here I have on my CAMWorks feature tree, I have a part that I'm going to machine, and right now I've already defined a boss feature. We're going to be machining around this boss. And this boss does have a spline shape. And if you look at that 2D profile, it looks pretty darn accurate. If I go into my operation tree and look at my toolpath, I have a contour mill toolpath, and you can see that toolpath is following that spline shape pretty darn accurately as well. If I hop back over to my feature tree, let's go ahead and go into our CAMWorks options, and let's take a look at what our current spline deviation value is. Under the Mill Features page, my spline deviation value is pretty small. It's 0.0001, which is my recommended value. This or smaller. What happens if I make this value large? So let's say I make it 0.5. And I'll hit OK. And I'll do a quick rebuild. If I hover over the irregular boss feature, you can see here that the spline is no longer accurate. And essentially you have all these facets. And literally that blue outline is what CAMWorks is going to try to machine. So you've lost a lot of accuracy there. If I go to the operation tree, you can see here that the contour mill tab is literally trying to machine that faceted shape. And even if I simulate this, you'll see that it is literally machining that faceted profile. So there you can clearly see how you can run into trouble if that spline deviation setting is set to too high. So be aware of that. Like I said, my recommended value is having it 0.00. Next, we'll take a look at the facet deviation setting. This setting is also under the Mill Features page. So when CAMWorks tries to machine a multi-surface feature with a 3-axis operation, it does not machine the actual model surfaces. CAMWorks actually creates a mesh of the multi-surface whose accuracy can vary depending on the facet deviation value. That mesh is what CAMWorks tries to machine. The less accurate the mesh, the more faceted your final machine surface will appear. Think of phase deviation as similar to spline deviation, except it's for 3D surfaces instead of 2D profiles. On the bottom image of the slide, you can see how the accuracy of the geometry you are machining decreases the larger your facet size. The image is shown on this slide shows you a real example of what happens when you have a large facet deviation value versus a small deviation value. The image on the left has a large facet deviation value, and the image on the right has a small facet deviation value. So let's take a look at what happens when we have a large facet deviation value. So here I've defined a multi-surface feature. Essentially, I just picked all the surfaces on this part. This really isn't a really good multi-surface feature, but nonetheless, I want to create a simple example so you can see the difference. So right now, this is my multi-surface features, all these surfaces. And if I go to my operations tree, I have here a roughing area clearance operation to machine that multi-surface feature, as you can see there. Okay. And if you look at the toolpaths, they're pretty darn smooth and accurate, right? They follow the shape. So if you look there, look at the arc, right? The arcs are pretty darn smooth. Now, if I go into CAMWorks options, under the mill features page, this is where I have this facet deviation value. If I modify this value, right now it's very, very small, which is good. That means I'm going to get a pretty accurate machine part. Now, if I increase this value to say 0.5 and hit OK, all right, and then I go ahead and rebuild this area clearance toolpath, notice that now my toolpath is not as accurate, right? You see how you can see some of those facets? And that is because the mesh that it's actually trying to machine is less accurate because we're using larger facet triangles, okay? So you can see clearly there that there are facets, and that's essentially what you're going to end up in your final machine part. So that's why I highly recommend that you have an appropriate value for your facet deviation. Okay. On the slide that I initially showed, I showed that a facet deviation value should be, my recommendation would be less than 0.001 millimeters or 0.00004 inches. And if you do have that value, that should give you a pretty smooth surface finish. There is another setting that I will mention that also has the potential to affect your surface finish. The setting is called machine deviation, and this setting applies to both 3-axis and multi-axis operations. It is the maximum amount that the cutter can deviate from the faceted surfaces of the model. The smoothness of a toolpath is based not only on the facet deviation, but also on the machining deviation. This parameter can be found in the operation parameters of individual operations. My recommendation is to have a value less than 0.002 millimeters or 0.0001 inches. Next, we'll take a look at some settings available on the update page. We'll take a look at some on-rebuild options as well as discuss 3-axis toolpath generation method. There is an option under on-rebuild called Add New Feature to Feature Tree. Otherwise, they are added to recycle bin. What this option does when it is checked on is when a rebuild is triggered, CAMWorks will rerun automatic feature recognition, and if new features are generated, they are added to your CAMWorks feature tree. This can get annoying because you end up with features in your CAMWorks feature tree that you did not want or are not using. It makes your tree cluttered and hard on the eyes. Rebuilds are triggered, by the way, whenever a design change occurs into the model. My recommendation is to have this setting unchecked. That way, if new features are generated, they are added to the recycle bin instead of your feature tree. Let's take a look at an example. So here I have a part that I'm going to machine. I've already have my mill part setup defined. I'm going to be machining from the top, and I'm going to go ahead and run automatic feature recognition for this setup, and in a moment you'll see a whole bunch of features were recognized, right? So let's say that maybe I didn't want to machine any of the whole features, so I can delete those, and I can even empty my recycle bin. And then so these are the features I wish to machine. I'll go ahead and generate operations and toolpaths for these. I'll generate the toolpaths. So here I have all my machinable features and all my operations to machine these features. If I right click and go to options, to my CAMWorks options, and under update, notice how this add new features to feature tree, otherwise they are added to recycle bin, is checked on. So let's see what happens. So if a rebuild is triggered, it's going to rerun automatic feature recognition. And then if it does recognize new features, it's going to add them to my tree. And once again, I don't want this because it clutters my tree. Let me show you an example of this. So if I go into my Feature Manager design tree in SOLIDWORKS, and let's say I make a design change. This pocket, I'm going to make it 1 inch instead. And I'll do a rebuild. And you can see my pocket is now deeper. Once I go back into the CAMWorks feature tree, it knows that a design change has occurred, and it says CAMWorks data needs to be updated. Do you want to proceed with rebuild? The feature tree has 14 automatically recognized features. CAMWorks will run feature recognition to rebuild these features. So it's going to run automatic feature recognition, and on the very bottom, it's going to also rebuild the toolpaths for any features that have changed or any operations that have changed. So if I hit OK, you'll see in my feature tree that I have all these new features that were added, as well as mill setups, which I don't want to machine those features, but now they are cluttering my tree. Now, no operations were generated, but in my feature tree, I have all these extra operations that I don't need. So that is what that option does. Whenever a rebuild is triggered, it's going to run automatic feature recognition, and it's going to any new features, it's going to add them to your tree. Now, it won't generate operations for them, but they'll be there, and they're kind of annoying. So let me show you, if I have that unchecked, what happens. So I'm going to delete these features here just to recreate the scenario. So I'll delete the setups as well, and I'll empty my recycle bin. So I'm back where I started, right? I have all my features that I actually do wish to machine. If I go to my CAMWorks options, and this time I uncheck add new features to feature tree, otherwise they're added to recycle bin. So I'm going to uncheck that. And now if I do a design change, so I'm going to make this pocket more shallow, so back to 0.5, and rebuild, and accept. Okay, so my pocket is more shallow now. When I go to the CAMWorks feature tree, notice I get that same warning. It will rerun automatic feature recognition if I hit OK, as well as update my toolpaths. But this time, it dumped all those features automatically into the recycle bin. It didn't add them into my active tree of what I actually want to machine. So my tree is not cluttered. And then, so that's what it does. And then my second suggestion here is, if it does throw these features in the recycle bin, leave them there. Do not clear out your recycle bin, because next time you do a design change, for example, if I go in here and I change it back to 1 inch, rebuild, hit OK, and I go back into the tree, it will rerun automatic feature recognition again, but because the features are already in the recycle bin, it's actually going to run a lot quicker the second time, right? Because they are already in the recycle bin. It's already recognized them. So once again, under CAMWorks options, my recommendation is have this setting off. That way your tree does not get cluttered with features, machinable features that you're not going to use. Next, let's talk about 3-axis toolpath generation method. This is an option that is also under the update page. And essentially there are two options: previous method and advanced method. Advanced method essentially uses the newest superior algorithm for improved toolpath generation for 3-axis toolpaths. When you select this method, your operations will have some advanced options in the operation parameters page, such as being able to use scallop, 3D step over, or bottom-up machining. The previous method option, really it's only there for the most part to support older files. This is the older algorithm, and it is essentially obsolete. Moving forward, you really should just be using the advanced method. But saying that, there are in certain situations where this method will actually provide better toolpaths. So really, previous method is really just there to support older files, but in some scenarios, it does give you slightly better toolpaths. But moving forward, you really should only be using the advanced method. Okay, so make sure you have an advanced method checked on under the update page. Next, under the display page, there is an option called Collapse Operation Dialog on Preview. This option will minimize your operation parameters menu anytime you click the preview button. This is very annoying. My recommendation is to have this option unchecked. That way you can easily modify parameters and preview toolpath changes without having to maximize the operation parameters menu every time. This tip is an absolute must. Here you can see sort of an example of that, right? Every time we change a parameter and hit preview, it minimizes. Okay, I don't want it to minimize. I don't want what is happening on the left image to occur. I rather have what's happening on the right image. I want to always leave the operation parameters menu maximized. Let me show you what I mean by showing you a real example. So if I go to CAMWorks options and I go to the display page, there is an option here called collapse operation dialog on preview. And you can see there it's clearly checked on. If I hit OK, and I go into any operation, and if I go, let's say, to my roughing tab, let's say I modify my step over to be 60%. And typically, if I want to update the toolpath to see the changes, I would hit preview. Now, what happens is the operation parameter screen minimizes, and then if I want to do another change, I have to maximize it. That is annoying. So my recommendation is, instead of having that, go to your CAMWorks options display page and uncheck the collapse operation dialog on preview option. Now, if I go into an operation, and let's say I make a change to the step over to change the step over to 20% and hit preview, I can update the toolpath and it doesn't minimize. And now I can easily modify it again if I want to and preview my toolpath. So this tip, as I mentioned before, is very, very, very useful, prevents extra clicks, and overall prevents you from wasting time. Next, I will show you how to recognize pockets with top or bottom fillets as 2.5 axis features. This one always frustrates students because when they first use CAMWorks, they think that pockets with fillets cannot be recognized as 2.5 axis features. They believe they have to define them as multi-surface features. Well, you can actually do both if the pocket simply has a top or bottom fillet. In order to recognize a pocket with a top or bottom fillet as a 2.5 axis feature, you must use automatic feature recognition, specifically local feature recognition. They cannot be recognized interactively. Let's take a look at an example. So here I have an example of a part that has various pockets with fillets. The first three examples have pockets with either a fillet on the bottom, on the top. In this case, it has a bottom and top fillet. And the third example is a more complex example where there's actually fillet on the top, bottom, and in the corners. Okay, these first three technically can be recognized both as 2.5 axis features and multi-surface features. The last one here on the end, that one should be recognized as a multi-surface feature. Okay, so let me show you how I can recognize these first three as 2.5 axis features. Once again, you could recognize it as multi-surface features as well, but most users, they are not quite sure how to recognize these as 2.5 axis features. So I'm going to go to the CAMWorks feature tree. You can see here my setup's already defined. And what I need to do is I need to use recognize local features to recognize this pocket with a fillet. The way you do this is you actually just pre-select faces, and then you right-click the setup and hit recognize local features. And here you can see that it recognized the feature. If I actually click rectangular pocket 1, you can see here that the top and bottom profile were recognized correctly. And I could do the same thing for these other two examples. If I right-click setup, if I pre-select the faces, and you actually don't even have to select all the faces. You actually just select one of them and right-click and hit recognize local features. It recognizes the feature. If I click rectangular pocket 2, you can see that the top and bottom profiles in red were recognized correctly. And I could do the same thing for this third one. I can click the bottom face, or I can select all the faces in there. Right-click and hit recognize local features. And once again, you can see that it actually did recognize the profiles correctly. Okay, so for these first three, that's how you can recognize pockets with top or bottom fillets as 2.5 axis features. And just to prove that this actually does work, I actually just generate the operation plan for this third pocket and generate the toolpath. You can actually see for the rough mill and the contour mill operation that the toolpath does reflect that it is recognizing the fillets. Okay, here's the same thing for the contour. If I want to make it a little more obvious here, I can adjust my depth of cuts to, let's say, 10%, preview, and there you can see in the toolpath it does actually take into account the fillets. All right. Now this fourth example here, because you have fillets in the corners, you do not want to recognize this as a 2.5 axis feature. And in fact, it won't recognize it correctly. This would be an example of a multi-surface feature. So this type of pocket, you're going to want to recognize it as a multi-surface feature. The way you would do that, right-click, go to your feature tree, right-click, hit multi-surface feature, select all the faces contained. Once you select all the faces, that's your multi-surface feature. Okay. Here in your multi-surface feature, you can, let me modify the strategy. I'm going to do area clearance Z level. Okay. Right click, generate operation plan. I have an area clearance in a Z level operation. Generate the toolpath, generate the toolpaths. And you can see, for example, on the Z level that it does take into account all those fillets. Okay. If I go to area clearance, I have to actually add a containment area in this case. Don't worry about that for now. The point is for complex pockets like that, you're going to have to recognize it as a multi-surface feature. For certain pockets, if it's just the top and bottom fillet, you actually can recognize them as 2.5 axis features if you want, or you can just recognize them as multi-surface features. To be honest with you, multi-surface features have a lot more options and parameters that you can play with, so sometimes you are better off recognizing it as a multi-surface feature, but once again, you do have the option of recognizing the first three here. Pockets with top or bottom fillets, you can recognize those as 2.5 axis features. You just have to use recognize local features. Okay. Next, I want to explain the difference between 2.5 axis volume mill and 3 axis volume mill. Volume mill, as you know, is a high-efficiency tricoidal toolpath that allows users to quickly rough out material by using the full flute length of your cutting tool, small step overs, and large feed rates. The toolpaths only use arc motions and do not wear out your cutting tool as quickly. So this is an awesome toolpath. In CAMWorks, there are two types of volume mill. One is for roughing out 2.5 axis milling features. This comes included with SOLIDWORKS CAM Professional or any of the CAMWorks licenses. Then there is 3 axis volume mill, which is for roughing out multi-surface features like the one you see in the image on the right. 3 axis volume mill, like I said, is for roughing out multi-surface features. This is a separate purchase and it is not included with any of the SOLIDWORKS CAM or CAMWorks licenses. So this is a separate purchase. So just want to clarify what those are. Most users aren't aware that there is a 3 axis volume mill, but that is what it's for. If you're trying to rough out a multi-surface feature, you have to use, or using volume mill, you have to purchase 3 axis volume mill. Next, we'll take a look at some simulation options, such as holding the shift key up to current and increasing number of. The first option we'll take a look at is holding the shift key. So whatever you're simulating, maybe you're only trying to simulate up to the contour mill 3 operation. If I just simulate this operation by itself, it only simulates that operation and the previous stock is not being displayed. Let me ignore these collisions for now. So as you can see here, all the previously machined stock is not being shown for all the previous operations. So if you actually want to simulate this operation, but also see all the removed stock from the previous operations, all you have to do is hold the shift key, right-click the operation, and then hit simulate while holding the shift key. And this will pop up this operations for whip menu where it will allow you to select which operations should also be simulated in the background. So for example, all these will be simulated in the background, and then I will continue the simulation with contour mill 3. So if I hit OK, you'll see that my removed stock is being displayed, and then if I hit play, it continues simulating my selected operation. The awesome thing about holding the shift key too is it can work even through multiple setups. For example, here I have a mill setup 2. If I hold the shift key and simulate this contour mill operation, it will actually allow me to simulate all of the previous mill setup operations as well. One thing to be aware of is it does take a little bit of computer resources to simulate all these operations. So make sure your simulation options, your quality is not set to too high, or else sometimes it will cause a bit of a lag or potentially a crash. So make sure you save before you use this shift shortcut. So you can see here, it simulated all the operations even in previous setups, and then I could simulate the current operation. The next tip I'll show you is up to current. Up to current does something similar. It's not as powerful as holding the shift key, but it also works. And this only works for one setup. For example, if I go back to this contour mill 3, and if I just hit simulate, there's an option here. There's called up to current. And if I hit play, it'll simulate all the previous operations in the background very quickly. And then I could simulate the selected operation, which was the contour mill 3. Once again, this only works for the current setup. Unlike the shift key, it will not simulate across multiple. It will not simulate in the background across multiple setups. Finally, another simulation that is useful, or another simulation option that is useful, is this update display at. Sometimes, especially with multi-surface features, this obviously is not this part does not contain any multi-surface features. But if you do have a part that has complex multi-surface features, you can actually help the simulation by increasing the number of moves. For example, I can say update the stock every 50 moves, and it will allow me to speed up the simulation. So only the stock will update every 50 moves. You could do every 500, every 1,000, and so on. Okay. This also works in turbo mode. If I hit turbo mode and I hit play, obviously this is not a very complex part, but it will actually, this will actually only update the stock every 1,000 moves. So let me pick something smaller, maybe every 20 moves. Okay, if I hit play, kind of hard to see there because it's simulating so fast, but essentially it's only updating the stock every 20 moves. This, like I said, is very useful in multi-surface features. If you don't want to see the tool run turbo mode, and then you can have it just update every 20 moves. I'll set this back to 1. Another thing that I'll also point out, in case you aren't aware, is there is a simulation options menu. Okay, and whether you're in tool mode or turbo mode, there is a quality setting in here. Okay, if you want to run your simulation fast, you can decrease this turbo mode or tool mode resolution or quality setting, whatever you want to call it. Okay, my piece of advice is always have this dialed a little back and never have these settings all the way to the max. Okay, always kind of dial them back a bit. That way your simulation runs quickly and smoothly. If you do have it all the way to max and you have a complex part, you'll see that it is going to use up a lot more computer resources. There is a big jump from here to the max setting. So I always like to have this a little bit back. That way my simulation runs smooth and it doesn't take forever to run. So that's another setting you want to be aware of. So speed, if you dial it down, the quality of the simulation is going to go down, but the speed is going to go up. If you set it to quality high, the quality of the simulation is going to be very accurate and high, but it may slow down the simulation. So I kind of have to choose your poison there. So those are some simulation settings and options. Next, we'll talk about using SOLIDWORKS sketches to define machinable features. This is more of a reminder. We learned this in the first SOLIDWORKS CAM standard class, but typically this is something users forget that they can utilize, but not only can you select model edges and faces to define 2.5 axis features, but you can also utilize SOLIDWORKS sketches. This can be done for both milling and turning. Let's take a look at an example. So here I have a part, and it does contain a couple SOLIDWORKS sketches that I manually created. You can see here. Okay. And so, like I mentioned before, whenever you're defining a 2.5 axis feature in CAMWorks, typically we would select model edges or faces to define our 2D profile. The one option that we always tend to forget is that we could also utilize SOLIDWORKS sketches. Just to show you an example here, I'm going to go ahead and define a 2.5 axis feature. I'm going to create open profile feature. And for my selected entities, I can select any of my available SOLIDWORKS sketches. So I'm going to select this open profile sketch. And I'll define my edit condition. So I can define my depth. So I could pick whatever depth I want. maybe up to here. I'll accept. If I go ahead and generate the operation plan and generate the toolpath, you'll see that the toolpath follows that sketch. So here is an example where I don't have to actually use a model edge or faces to define my 2D profile. And I can do this with these other sketches as well. So this is just something to be aware of. You could also do this in turning as well. You can use SOLIDWORKS sketches to define your 2.5 axis features. So don't forget this. This sometimes can solve or could be useful in certain situations. So don't forget that this is possible. So there's an example of using SOLIDWORKS sketches to define sheetable features. Next, we will discuss how to create single plunge groove cuts. So this would occur when the groove insert width is equal to the width of the groove of the part. Thus, no stepovers are required, and all you have to do is do a single plunge cut. This has to be done in a special way in CAMWorks. You have to either define this as an OD or ID feature, not a groove feature, and you have to, under the Turn Finish tab, you have to select diameter and length pattern for your pattern option. Let's take a look at how this works. So here I have a simple example where essentially a single plunge groove cut is required. I have a groove here that is 0.118 wide, and I'm going to be using an insert that is exact same width. So I only need to plunge down with the groove insert once with those stepovers. So here you can see I have an OD feature defined, and under my operations tab I have a turn finish operation, and if I step through it, you can see what's happening. My groove plunges down to the required diameter and then pulls out. So only a single plunge groove cut is required here. In order to do this, there's sort of some specific settings that you have to follow. If I right click the turn setup and select turn feature, I will go ahead, actually before I do that, let me go ahead and delete this completely. So we'll start from scratch. So in my turn setup, I'm going to create a turn feature. It has to be an OD or an ID feature. When doing single plunge groove cuts, you cannot select any of the groove type options. You have to select OD or ID. Okay. Technically, you could do face feature as well. In my case, I'm going to pick OD feature. Default strategy, I'll leave it at rough and finish. And for my selected entities, I'm going to go ahead and select this slide right here, the line out the groove, and I'll accept. So I have an OD feature there. I'll go ahead and generate the default operation plan. I'll delete my rough build operation because I don't need that one in this case. And let me modify some parameters in turn finish in order to make this work correctly. So go ahead and edit this. The first thing I have to do is I have to change the tool. It thinks I'm using a finishing tool. I should be using a groove tool, so I'm going to select my 0.118 grooving tool and hit select. Next, I'll go to the turn finish tab. This is the important step. I'm going to select diameter and length. Okay, diameter and length, essentially what you want to define is to what diameter are we plunging to. So in my case, I'm plunging to this diameter, which is 1 inch. So I'm going to put in 1 inch. Next, I have to define essentially where I'm plunging. So if this is my starting point, I want my cutting tool to plunge halfway. So essentially all you have to do is, since my grooving tool is 0.118, I just have to divide it by 2. So if I hit preview, you can see that there it plunges down right to the middle of my groove. It offsets it by whatever this value is, which technically is 0.059 if I want to type it in. It's the same thing. You can see there. You might have to modify some settings. So like under the NC tab, for example, you may want to change your radial distance to maybe like 0.2, retract distance to 0.2, and then biaxial is going to be 0. And you can see that should fix, that should prevent any gouging there. So you may have to play around with your clearance options there to make it work correctly. If I step through this, you can see clearly here, it's doing a single plunge groove cut. So that's how you do single plunge groove cut. So this is only when there's no step over requires. This is the way to do it. Okay. So that is how to create a single plunge groove. For our last tip, we will take a look at how to deburr the bottom of a hole with 2.5 axis features. There are special tools that you can purchase, such as this back chamfer tool that allows machinists to deburr the bottom of a hole. You can see an image of such a tool shown in the slide. In order to do this, you will have to create a user-defined tool, define a pocket feature, create a contour operation, and use a negative allowance. Let's take a look at an example. Now, before we look at the example, I will also mention that you can also do this using multi-axis operations, but it's a little bit more tedious. This is more of a quick and dirty way of doing it without having to mess with a whole bunch of parameters. So let's jump into the example. So in this part here, this example, we already have, let's just say the hole is already there. All we need to do is deburr the bottom of the hole. So what I've done here is I've created a pocket feature, and then I used a contour mill operation to deburr the bottom of the hole. So let me show you what I did. Let me go ahead and simulate this. So essentially here is my starting stock, and all I want to do is deburr the bottom of the hole. If I step through this, you can see there, I have my user-defined back chamfer tool, and I want to be able to do that. Chamfer the bottom of the hole from this setup direction. All right. So let me go ahead and delete this feature, and I'll show you from the beginning how I did this. Okay. So the first thing I want to do is under my mill setup, I want to define a 2.5 axis pocket feature. And I'll go ahead and select my profile and then my end condition. Okay. So this essentially is my hole. I will modify this later on and make it a little bit deeper. That way I machine at the right location. But for now, I'll leave it like this. And I'll hit OK. Or actually, before I hit OK, I'm going to create just a finish strategy. So I just want to create a contour mill operation. I'll go ahead. So there's my circular pocket feature. I'll go ahead and generate the default operation plan. And that creates a contour mill operation. Inside of here, I'm going to go ahead and pick a different tool. I've actually created a user-defined tool that's already in my tool crib for this back chamfer tool. You can see it right there. And I'll go ahead and hit select. And I've hit preview. Again, there's some issues with the lead in and lead out. Okay, that's fine. So let me go ahead and go to lead in, lead out. I'm going to go ahead and remove gouge check. You can see what's happening there. Essentially, it's gouging out to the side. All right. So what I could do here is I could go into my lead in page, and for my lead in and lead out, I'm just going to select none. And that way I don't have a gouge. I can turn the gouge check back on. And so you can see the tool goes in, and unfortunately it's doing 2 step downs, which I don't want. From here, what I want to do is under my contour tab, just increase the first cut and final cut amount. Just put in a large value so it does it. It goes all the way to the bottom of the hole. So let's just say I pick a large value like 2 inches. Hit preview. And now it's just going to the bottom. So let's simulate this and see what is happening. So the tool comes down, and then it machines around. Now it's not cutting any material, so if you want to actually cut material, we have to add a negative allowance. Most people are unaware of this, but under side parameters where it says allowance, you can actually use negative allowance values if you want to overcut. So let's just say I pick negative 50,000. Hit preview. My toolpath updates. Now if I simulate this, you can see here that it's actually gouging the part. But it's gouging it at the right location because it's machining using the bottom of my tool. Or sorry, it's the bottom of the feature. It's only going to the bottom of the feature, and that is being referenced from the bottom of my tool. So I have to make my feature a little bit deeper. Okay? So I'm going to go ahead and modify my 2.5 axis feature, pocket feature, so it's a little bit deeper. If I actually take a look at the user-defined tool and look at some of its dimensions, notice that from the middle, that's where it's actually cutting at the moment, to the bottom, all right, it's 0.114. So that's how much extra material I'm going to add, or how much extra depth I'm going to add to my pocket feature. So I'll jump back into my deburr feature. I'll go into my CAMWorks feature tree, and under circular pocket, for my end condition, instead of picking up to face, I'm going to pick offset from face, pick that bottom face, and that distance is going to be that dimension I saw earlier, 0.144. Okay, and then I'll accept. So you can see it just increases the depth of my hole by 0.144. If I go back into my operations tree, you can see here my toolpath updated, and now the tool is going to go all the way to this position. And if I simulate, you'll see that now it goes down to the bottom, and now it actually chamfers the hole. So that's kind of a nice, quick and dirty way of machining or deburring the bottom of a hole using a back chamfer. So one last item before we jump into the Q&A portion is, in case you're not aware, GSC is owned by Ellison Technologies, which is a machining solutions provider. They provide machining centers from turning centers, mills, EDM, and even robots. So just to make you aware, if you are looking for CNC machines, feel free to reach out to us, and we can have our Ellison Technologies parent company reach out to you. Ellison Technologies sells primarily Doosan machines, but they also sell other CNC machine manufacturers as well. But their bread and butter are Doosan machines, which are very rigid and reliable machines. So if you are in the market for a CNC machine, let us know and we can give you some contacts or have somebody reach out to you. That being said, let's go ahead and move on to the Q&A. So that's it for today. Does anybody have any questions? So if you have a question, feel free to unmute yourself and ask any questions. So let me know if you guys are curious about it. So it looks like, Paul, you have a question. Can you use G41, G42 for a multi-surface Z-level cutting? I don't believe you can. I would have to check that out myself. I know you cannot use it for like multi-axis operations. For multi-surface, I'm gonna say no at the moment, but I could check up on that one for you. But I'm gonna say no. I think if you're trying to adjust, maybe like for compensation, you're probably gonna have to put like a negative allowance in there. So, but I'll check that one on my end. I know you cannot do it for multi-axis operations, but it might also be for multi-surface features. Okay. Any other questions? So Louis, you have a question, it looks like. Louis, was that a question or an answer to a question? I see you're typing in the chat there. All I see is can you lead out from bore? That, I'm not understanding the question on that one. Let me see if do I have to unmute you? You're self-muted, so you guys.
Can you hear me now? Can you hear me?
Yep, I can hear you now.
So my question is for the bore, when you're boring, and for example, I'm about to finish my final bore operation, the finish operation, I'm gonna come out. I want to come out the minimum amount on X, and usually I have a hard issue setting, having those settings, adjusting those settings. Usually I just want to retract like maybe 50 thousandths on X from the finished diameter.
Sure. So
That's
there should be some settings in the NC tab, right? Have you been using the NC tab, correct?
Yeah, but it's got, I usually have a hard time with that. So I don't know if you could show me something real fast.
So let me see if I can actually share my screen. Sorry, so like there's two screens here, go to training. I don't think I can actually share. Let me see. Let me make myself.
I think I can switch you real quick. One second.
Okay. All right, there we go. So Katie, it doesn't actually let me show any of my screens. I think should I click make myself presenter maybe? It gives me that option.
You should be presenter now. There we go. All right.
There it is. All right, so let's see what screen I'm showing. One. Okay, so let's see if I can show you something. I'll just pull up a real quick example. But you should be able to control how much it clears out from the bore using those NC options. Oh, it looks like I already had a software open. Sorry, one moment. Let's see if I can open up a quick example for you. Let's go for some training files. Okay, so this part's got a bore in there. Okay, let me open this up. Okay, so bore rough. Let's just do the bore finish just to make it simple, I suppose. Can you see that okay, Louis?
Yes, I can see it.
Okay, so inside of here, so right now it's going there. So you're probably thinking more for, like a finishing up or a boring, or I guess
finishing. I just want to retract. Sometimes it wants to go too lowered, too down, and my boring bar is gonna hit the stock or the part.
Okay. So let's look at this. So right now it's going in, right? It's going like that, and then there's the clear out, right? Right there.
Yes.
So if you go into the NC tab, this is where you can control essentially your approach and retract strategy. So when you pick auto, do you know what auto does by any chance?
No, tell me.
Okay, auto can do two different things depending on the situation. Okay, so let's just talk about in terms of retract, right? So how is it going to retract? When you have auto, if the next operation is a tool change, then it's going to clear out to the preset positions or the home position. Okay. In the machine tab, there are preset home positions that you can define. And so if there is a tool change, it knows that it has to clear out and go to that position so it can do a safe turret change. And I can show you where that is too as well. If there is not a tool change, then auto will go to the previous position of the previous tool. So, or the previous operation, right? Because it's the same tool. It'll just go to wherever the previous tool left off and continue from there. Now you can manually change this. So if you want more control, for example, if I pick, so here, let me show you. Preset point, what that does is that'll go to a preset position that you define in the machine tab. So don't worry about that one for now. Retract point, I think, is what you're looking for. And what retract point does is you can manually define where it's retracting. See that little red dot?
Yeah.
And if you go here to retract point, you could actually manipulate it. So see how I can move it?
Yes.
Okay. And you can move it over here. So wherever I want. And if I hit preview, notice that it's going to retract to that point. Right? And you have various settings. You could do it from the setup origin, define this distance from the setup origin, for example. So if like I have 0 set here, I hit preview, it goes to the origin, your work offset, right? And then you could define your dimension from that point. Okay. In your case, probably what you want, I mean, it doesn't matter, but this will do it from the clearance position. So that's the, if I set this to 0, sorry, there you go, 0, 0, okay. I can, if you want to increase the X, for example, from that point, I can make it, or in this case, it'd be negative because it's boring, right? I can make it here and I can make it go over here. And that'll be my clear out.
So use the clearance X. Retract point, and clearance X, clearance Z.
And then notice here, there's also a strategy available. So this tells it that it's going to clear out in the X first and then in the Z, right? For boring, that's kind of critical because they're also going to run through the part. So here you can say Z and then X. That's no, so that'll retract straight out. So if I hit preview, it'll retract straight out in the Z first and then down.
Okay.
Okay. So depending on your geometry, obviously, in this case, I want X first and then Z. And then, so if you wanted to clear out all the way out of the part, then, you know, I could just increase my, this is just a finish patch, right? So we're going to make it clear out of the part, right? And then hit like that, okay? And then you could do the same thing for your approach position, right? So if you want to pick a different approach position, you could also define it in here, okay? But that's essentially what it's doing. If I hit the step through, like I said, it's starting from there, which is probably not a good point, but point is, my retract, you can see there, it's clearly going to where I told it to go.
Okay.
All right. Does that answer your question?
Yeah, that's my question.
Okay. Another thing I'll point out too is preset position. What that actually is if you, let me exit out of here. If you go to your machine tab and under posting, see, have you ever messed with these values here? Preset position?
Yeah, I was sometimes I gotta change them when I'm using like a generic post. I have to change the 10 to a 5 because it doubles it to 20.
Yeah, it does radial, right? The X is radial, so it will double it, right? So that is that preset position. So every time there's a tool change, it goes to this position here. The point of this is it's kind of like a home, go to home thing, right? But instead of making your tool go all the way to home to the tool change, you can pick sort of a closer point where it's still safe to do the tool change.
Okay.
Right. So you can make a point that it's still safe, but it doesn't have to go all the way to the machine home position, right? And then you can do the change there. So that's what that is. So if I go into, I guess I'll go into the boring one, that it should be what preset does. You see it right there? It's going to X10, Z5, but I think the output will actually be X5, X20, right? So as you know, that aware of it does radial X for some odd reason. But that's what preset position does. It's going to go clear out. You can see it right there, right? It clears out to that preset position for a safe tool change. Okay. So you can manually force it to go in there. And then you could also do retract point and then preset. So let me actually change back to the board finish because that one's a little bit better understood. Okay. So preset position is going to make it go all the way to that preset position. And then you could do retract in preset position. So what that does is I can manually define a point, right, using these values. So it's going to go to this point right here, and then it's going to go to the preset position. So you're kind of adding a little in between point and then go home. That makes sense? Okay. So that's it for that. Any other questions here? All right, so last call. Any more questions? All right, so Paul, you're talking about the multi-surface feature. Let me actually see. I'm leaning towards no on this one. Let me see if I can open up a file. Let me open up a multi-surface file really fast. I know for sure you cannot do it for, like I said, 5-axis or 4-axis operations, simultaneous operations, I should say. So let me look in lesson 8. Let me just open up a quick example, and I'm pretty sure the answer is no, but let's just double check. So here I have a multi-surface feature clearly, right? Operations here, and if I go to, let's say, Z level, and I don't think you're going to find a setting in here for G41, G42. It's looking really fast, and C usually I think it's under the NC tab, so that'd be no. No, I'm going to say that's a no. Okay. So a lot of users, if they do need to adjust for, so like a lot of people like using G41, G42, maybe they're off by like 1,000 or something and they just want to recut it. A lot of people will put like a negative allowance in the value, right? So remember how I said you could use negative allowance? So that's one way people get around that. So instead of making the allowance 0, they'll make it like negative 1,000 or something, right? Or whatever the case may be. And sometimes that'll work. But yeah, unfortunately for multi-surface features, yeah, you can't use G41 or G42. All right. Anything else? Any other questions? Okay, other than that, hopefully today's presentation, you find at least a couple useful things that maybe you weren't aware of. Other than that, thank you for attending. And as always, if you do have any other questions, feel free to reach out. Actually, we do have one more question here coming in. Can you add text operation as a probe presets? I'm not sure. You might have to explain that one. I'm not sure I fully understand that one. So yeah, text, so variable example number 666 is equal to 55. That will post out. Paul, do you by any chance have a mic they may be able to speak into? And maybe you can explain that a little bit, explain it to me a little bit more clearly. We can do a lot of magic with post processor. So post processing can do a lot of things. So we just have to understand.
Sorry, can you hear me?
Yep, I can hear you now.
So quick question, I'm kind of new to it, so I hope I can explain it clearly enough. But in other CAM systems, what I have a operation that drills a hole. Then I have an operation that does measurement on it with a probe. And I know we can do that a little bit. I've seen at least that it is possible to program the probe. But before I use the probe, I need to set some variables. So some of the CAM system that will allow you to put basically a manual text where it will get printed out or posted out with all the other operations. So before the probing operation, let's say I want to preset some variables, whatever, number 66 to 50, number 67 to 75, or what have you, I could put that in the tree and that would get posted out with all the other operation. I'm not sure if that makes sense.
We could absolutely do that. That would be a post-processor modification. We've done it before. Let me see if I can open up an example post from a customer. Well, you can see that you can actually add. Have you used post operations before?
Yes, I've used it, but I had a hard time to post it out, and B, to add multiple lines. It usually allows you only to do a one line.
We could do multiple, so we could definitely do multiple. So the one I'm about to show you, I had a customer, he wanted that, where he wanted to manually input his own codes or expressions in between operations, right, for whatever reason. And so we actually made a post operation where he can manually fill in up to 5 lines, 5 blocks, whatever he wanted to fill in. So we can absolutely do that. Let me see if I can find an example for you. This would be, give me one moment. Let me see if I can find here the example that I'm looking for. Here we go. Okay. So don't worry about this one. Why didn't you like that? Oh, maybe not this example. One moment. Another example here.
And I'm going to ask, because I can, is there any way you could share that post, at least the part of it where it does that, where it allows it?
The post process, so this is a customer specific one. So if you wanted to use it for yours, you would have to essentially purchase a custom post processor from us, and then we would add that change to it.
Got it.
Okay. My software is not. I opened too many software windows. There we go. Sorry about that. Just close this. Let me force it. It's been a long day for the computer, I suppose. Let's see. Get out of there. Not what I want. Come on. Okay. Try to see if this one works. Okay, sure. Okay, so this one, they had, this is actually for a Haas horizontal machine. Let me see if this is the right post processor. We made a couple of changes to his. So if you ever do want changes to your post processor, we can do it. It does come at a charge, but we can definitely do it. So I think this is the latest one. Actually, I'll pick this one. Okay, so they had this setup where they had this 4 parts they're going to machine on a horizontal. And under the operations here, I do have, and you can see he's actually doing a whole bunch of probing stuff here. Okay. If I right click here under post operation, we added this operation here called output strings.
Oh,
and inside of here, we can manually type in, G02, whatever you want to type in there, and it'll throw it inside of your G code.
Awesome.
So just as an example, let me see if I add something in here. Post operation, output strings, and you can put comments in there too, so you know what each one of those blocks are. So I'm just going to type random stuff here. Okay. I'll insert it in there. So it adds a post operation in there called output strings, right?
Got it.
And then if I post this out, you should see them at the very beginning because that's where I added them. So you see right there, hello, bye, what I added, and you could add comments. Is that what you're looking for? Be able to manually add blocks essentially?
That's what I need. Thank you so much.
Yep. So we can do it. Like I said, we'll have to make a custom post processor for you, but there will be a charge to it, and it just depends on your level. If it's just for like a 3-axis machine, then it's like I think around $850, I think is what we charge. The good benefit of that is that when you do purchase a post processor from us, you can make changes to it up to 12 months from your purchase. So if you decide to want to make a change later on, or you have a preference, we'll be able to make it a change to it up to 12 months from the date of purchase.
Great, thanks.
Okay. Any other questions? Anything else? Okay. I don't see any more questions. So if that is it, once again, thank you for attending, and feel free to always reach out if you have any other questions. So have a good one, everyone. Bye.